Page 3 is the synchronization notes. This is section 2.2, so it's the second use case, and it is mutual exclusion. So I guess that name means that different tasks are they're excluding each other from doing something at the same time. So what it does is it protects code that accesses shared data, and such code is called a critical section. So I've written that in green to emphasize that that's a key word. So it protects code that accesses shared data by using the semaphore as a lock. And there's actually a special type of semaphore, we'll get to this later, called a mutex, which is used specifically for mutual exclusion. But you can do it just with our general hypothetical semaphore. So here are the steps that you would take when you're doing this. So the initial value is going to be equal to 1. So the semaphore is often called, in this case, a lock, and one task will acquire that lock. It will decrement the semaphore to 0, so it gets to access the shared data. When it's done, it will give back the lock, it will unlock it and set it back to 1. So step 2 is that we will wait. We'll wait to, I'm going to use green here again, acquire the lock before entering the critical section. And step 3, I think you can maybe anticipate, will be to signal the lock to release, or signal to release the lock when leaving the critical section. The analogy that Peter Buer from computer science likes to use is a bathroom. You only want one person in a bathroom at a time. So you lock the door when you go in and you unlock it when you leave. So maybe that'll help you to remember. Okay. So let's do a pseudocode example. So we've got our hypothetical semaphore type. And this time let's call the variable lock. And we're going to initialize it with the value of 1. And again, we have 2 tasks. So task 1 and task 2. And we will loop forever, both cases. And so task 1 will do some kind of processing, do something with inputs, generate outputs, and now it's going to want to update some kind of shared data. So what it will do is it will wait on the lock to acquire it, so that will decrement the lock semaphore down to 0, and it will execute the critical section, so it'll do some processing, and then when it leaves it will signal the lock, and it might do some more work, and then it will loop around again, and eventually it will want to lock again, and so on. So we have the acquire step up here, and the release step down here. And task 2 is identical, but I'm going to fill it in just so that you've got it. So it does some work. It will wait on the lock before it enters the critical section. So then it will execute its critical section, which is reading and or writing this shared data. And when it's done, it will signal the lock. Do some more work, rinse and repeat. And you can see here that you have to depend on your task to behave properly. So they have to acquire, work with the shared data, and then release at the end. So it's up to the programmer to identify what code is accessing shared data, and to remember to both acquire the lock and to release it. Sounds easy, but it's easy to mess up too.